Hi everybody, welcome to the course and welcome to the first lesson. What we're going to talk about in this lesson is defining data mining and advanced analytics. Now of course the tool that we're going to be using in this course in Modeler, and we'll have plenty to say about that, but we just want to make sure that we're clear on the exact topic and the exact kind of methods that we're going to talk about. So this will be the first of some preliminary lessons that we'll want to do before we get talking about the software in depth. First, want to make a little comment about Qubit. My name is Keith McCormick. I'm the General Manager of the Advanced Analytics team for Qubit, and I'm going to be presenting this material with my colleague Jesus Salcedo, who's Director of Training for our team. Please do check out more about Qubit and about us at qubit.com. This next image is about the simplest one of a modeler stream that one can imagine. When you're using Modeler, you're drawing a flow chart. And as you can see in this flow chart, we're using the historical data to find a pattern. And that pentagon shape is what helps us find the pattern. The resulting pattern is in the form of a diamond, or a lot of times folks say gold nugget. In the history of the software, actually underscores this whole notion that maybe we're talking about a gold nugget. The software was originally called Clementine, and the name came from the song about the gold miner that you may have heard. Notice as well that we're letting the current data flow through that model, and very often we send that out to another file for scoring. There's all kinds of more elaborate things we can do, but that's just about the simplest notion of what we're doing in Modeler that one can imagine. Reading in data, finding a pattern, then presenting that pattern to newer data, and then trying to make predictions. That's the whole basic idea. Well, before we get further into the details, I want to make a couple of recommendations. This book has always been one that I think is a good one to recommend to folks that are new to data mining. Make sure you get the third edition. Third edition actually has been out for many years now. It's a substantial book. It's almost 1,000 pages in length, but it's very readable. It has some technical aspects to it, but it's not terribly technical, and it's not particularly about software. So you're not going to learn anything about Modeler in this book, but you will learn a lot about data mining. There's one particular section from this edition that I think is quite useful. It's the authors, Barry and Linoff's own take on the key aspects of data mining. That the whole idea is to notice what customers are up to, remember what they've done, learn from what the model has remembered, in other words, remembered here as historical data, and then act on it. I have my own definition, which we're going to see in a couple of moments, but this is really just a warm-up, and of course this isn't a formal definition. But again, highly recommended this particular book. Another author that you'll hear about quite often is Thomas Davenport. In the case of Competing on Analytics, he had a co-author, but he's written a number of books, sometimes with different co-authors, sometimes on his own. Very well thought of. This book has been out there for quite a while now. This is a great one to read if you are a manager of analysts but won't have the time or opportunity to get into the depths of the analysis yourself. Great one for that. It's also a great one to recommend if you are an analyst but you're trying to provide some context to your boss or senior management. Something that I want to mention about how we use the term at Qubit. We generally refer to predictive analytics more often than we prefer to data mining. For our purposes, they are very, very similar, but we're using predictive analytics as a little bit more of an umbrella term. To pull away and define it even more broadly, we mean advanced analytics to be the powerful combination of both predictive analytics and prescriptive analytics. And I have a little bit more to say about that here. When we describe things like reporting, we're really talking about things that are more like what folks might call business intelligence, or when we define that more broadly, reporting, calculation, analysis, monitoring, and so on. At Qubit, we tend to refer to that as business analytics. There aren't always tremendous clear-cut differences between them. There's a lot of overlap, but that's how we separate two teams at Qubit. We talk about the business analytics team or the advanced analytics team, and we find these distinctions useful. Predictive analytics is really where we're focused in this course, and then prescriptive analytics is quite simply, once you have an accurate prediction, what is the optimal action to take? So as a quick example, let's say as a customer, I qualify for 3 different marketing offers. You might not want to present all 3 of them to me. There might be a certain amount of fatigue associated with getting all of these offers. So ideally what you want to do is you want to figure out what's the best offer of the 3 to offer to me and perhaps suppress the other 2. You might say, well gosh, that's really easy. Why don't we just go with the one that has the highest likelihood of success? Well, I suppose, and that might actually turn out to be the best way. But you might also say that the second offer that has the second highest probability that I will accept it has a higher value associated with it. And when you look at both of those things together, you might decide that I should get the number 2 offer, not the number 1 offer. So actually there's a little bit more to it than simply looking at the highest probabilities. That will not be a focus of the course. I think it's important context, but we will be absolutely focused on the predictive analytics aspect. And the most important technique within predictive analytics, I think it's fair to say, is data mining. Another comment about this idea that advanced analytics is the combination of predictive and prescriptive analytics. There's kind of a neat marketing video that tries to illustrate this by way of formulas. Just a little bit of fun. You might want to check it out. Okay, so why am I using the term data mining in this lesson, even though a lot of folks are starting to use other terms, like predictive analytics or like advanced analytics? Well, I'm a fan of the document Cross-Industry Standard Practice for Data Mining. And it obviously is referring to its subject as data mining. So I continue as well. Also, there's an organization that I'm a member of and that a number of my colleagues are a member of, the Society of Data Miners. The term is absolutely still used. And there's enough momentum behind this that we will continue to use the term, again, even though there's competition for which term to use. Not exactly the same in all these cases, but all these synonyms. But a bit personal perhaps, but since I'm a fan of the CRISP-DM document, and a lot of folks that use Modeler are as well, I think there's value in continuing to use the term data mining. Now, if you go out onto the internet, shouldn't find it very difficult at all to get yourself a copy of the CRISP-DM guide. You should be able to find that readily available, and it's absolutely free. The whole idea of it being cross-industry is that this is not industry specific, nor is it software specific. It runs about 70 or 80 pages. It's written like an engineering document. So this is not going to be constant prose. It's going to be broken down into 6 phases, and you'll have sections like 1.1 and 1.2.4 and so on. But very helpful, and do take some time to go through it. Additional thing that I'll mention is in another lesson where we talk about CRISP-DM in detail, I find tremendous value in not just doing a very high level about the phases, but also the subtasks. There are quite a few of those, and we will be talking about those in the CRISP-DM lesson. Okay, so now what I'd like to do is walk you through my definition of data mining. I put a lot of thought into this. You'll come across a number of these. This is a tad longer than some others you may find, but the key point, and that's what we're going to go through here step by step, is there's specific components in this definition that I want to underscore. So the first thing I want to underscore is that when we're doing data mining, we're using historical data. And frankly, the data in data mining is often a bit older than you might imagine it to be. Let's say you're trying to predict college students that will graduate on time. Well, the data is going to be 4 to 5 years old. And the reason is, presumably, you're trying to make the prediction about their academic success based upon things that they provide in the admissions packet about 6 to 12 months before they attend. And the nature of the prediction that you're trying to make is that it won't happen now for another 4 years. So if you want to look at the most recent graduates that graduated yesterday, if it's in a university setting, you have to now go back into the historical data and look at what you knew about them when they were admitted. And that means that that data is going to be 4 to 5 years old. Okay? Let's say you're talking about cell phone contracts and you want to try to predict who's going to renew their contract at the end of the contract. Well, most cell phone contracts, at least in the US, where we kind of do this commit and you get the phone for free set up, well, those contracts tend to run 24 months old. So if you're looking at folks whose contracts just ended this month or are about to end next month, and you want to figure out if there's some pattern based upon that historical data, you could use some more recent data, but gosh, you're really interested in some of the things that they presented to you when they started those contracts. You want to include that data probably going all the way back to contract initiation. Could do it in more than one way, but that's probably how I would do it. You're going to need some data that's 24 months old. The other thing about data mining, which sharply contrasts it with statistics, well, and by statistics I mean hypothesis testing or doing experiments. Obviously, there are statistical aspects to data mining, but here I'm really focusing on the hypothesis testing aspect, and that data is normally collected in the context of an experiment. You can do other kinds of studies as well, but that's common. That's the kind of thing that you often learn about when you're taking Stats 101. Data mining data almost invariably is collected during the normal course of doing business. And it was first collected so you know what to charge the customer, or because you're keeping track of how much you spent on repairs, or you're keeping track of how much you spent on fuel or on marketing, whatever it might be. You're just engaging in running your business, and during that time you're collecting a ton of data. So then after the fact, you're looking at that data and trying to find patterns that you can leverage to save money or to make money or provide some value to you and your business. Data mining data is both selected and prepared a lot more than the uninitiated usually think. You might start with millions of rows, but only analyze 50,000. You might start with hundreds of thousands of rows and suddenly find that you have barely enough, that you really only have 2,000 or 3,000 that you can really bring to bear on a particular problem. Data preparation, this is kind of a famous thing. It's not clear who initially made this estimate, but it's frequently said that 70 to 90% of the time spent doing data mining is spent doing data prep. I think, truth be told, that really is probably combining data understanding and data preparation steps of ChrisDM, but nonetheless, it's definitely the lion's share, and very often folks in their first project underestimate just how much time will be spent on that. Also, terribly important, data mining and data exploration are not the same. Without a confirmation process, it's not data mining. It's something else. Now, certainly, there might be some folks that choose to use the phrase data mining to mean data exploration. And obviously, if that's how they choose to use the phrase, that makes sense. But it's not what is described in ChrisDM if you're not confirming that the pattern holds up against other data sets, not only the data set that you were using when you found the patterns or when the software found the patterns. For it to be useful, we're really seeking out previously unknown patterns. You should be hoping for an element of surprise when you're doing data mining. We're not simply confirming a hypothesis that we already had. We're rather trying to find something that we did not know and then confirming that it really is true, even on other data sets. So one could argue that the sequence of events that we go through in data mining is rather different than the sequence of events that we go through in a classical statistical situation, let's say like a drug study. It's really quite different. We're not starting with a hypothesis and trying to prove that we're right. We're rather trying to find a previously unknown pattern, but then confirming that that pattern holds up, that it really is a true pattern that we can replicate. We're building predictive models. So what's a model? Well, we're going to explore that a little bit, and then we're going to come back and talk about deployment. So let's talk about models. This is a simple model. Now, by the way, I borrowed this example from something that I found on the web, and I actually asked this gentleman, Professor Stevenson, if I could use this example from time to time. And he said as long as I acknowledged him, that he was glad to share it. What I love about this, because certainly I could try to put together a little data set like this, but what I love about this is what he's done with it. I urge you to check it out. He's a professor, as you can see, at Iowa State, and you can see we're not going to get into the math here, but if you're interested in the math, he will walk you through all of that. So here's a very, very simple data set. We're looking at the relationship between speed on the one hand and economy on the other hand. And what we find is that the faster you drive, the fuel economy goes down. A little sidebar, a lot of folks forget that when the 55 mile an hour speed limit was introduced in the late 70s, that it was because we were in the middle of the oil crisis at that time. I was quite young at the time, but I've always found that kind of interesting fact because, you know, we think that it was only about safety, and certainly slower speeds are associated with that, but the initial impetus was fuel economy. So very straightforward relationship, and we can see that written out in a formula there on the bottom right, that this relationship has been written out algebraically. Well, the formula on the bottom right is an example of a model. It's an awfully straightforward model. It's a very simple model. Doesn't take up a lot of space, but that's the whole idea of a model. It's simply a formula, it could be simple or complex, that helps us make a prediction. Now, in my view, and I feel quite strongly about this, I suppose reasonable people could disagree, but on this point, I really do believe I'm right. Unless you then deploy the models on future data and actually use it, not just throw it on a PowerPoint slide, but actually use it to drive better decisions in your business, it's not data mining yet. It's not enough to simply make a discovery and not do anything with it. It's not enough to make a discovery and simply share it with your colleagues but not act on it. You have to deploy it. And by deploy it, we mean something like this. By deploy it, we mean hook it up to the systems of the business. Hook it up to what the decisions that you make on a day-to-day basis. Run that new data, that current data, that ongoing flow of data through the model and help use it to make a prediction. Now, as we mentioned earlier, just a percentage chance in and of itself might not help you drive that decision. You might want to put an optimization layer on there. But what we're going to focus on in this class is just this aspect of it. Really where that gold diamond comes from in this diagram. That's what we're going to be focused on. So I hope you found that helpful. That is a quick walkthrough of what we mean by predictive analytics, advanced analytics, and data mining.